Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and hi, my name is Danish Imran, and today I would like to talk for our video presentation about PVT Analysis Report. So first of all, what is PVT? PVT itself stands for Pressure Volume Temperature. PVT Analysis Report is a fundamental component of the reservoir fluid studies in oil and gas industry. This analysis report is very crucial to provide physical and phase behavior of the reservoir fluid under certain conditions, which is very essential to provide the designing surface facilities, estimating the hydrocarbon reservoirs, and lastly to predicting the reservoir performance. For our assignment itself, we have given a lab tour during this PVT experiment. During this lab tour, we learn such things such as basic introduction to the PVT itself, material and apparatus used during the experiment, risk while performing the experiment, and lastly, the precaution while doing the PVT lab. From the lab itself and the material given, we can relate hand-to-hand sampling methods used to do the key lab test, which is first the flash test, or we can say the CCE test. Second one is the differential test, and the last one is the separated test. Apart from the notes given from our lecturer, we can assist the notes given by completing the analysis report to find the boiling point pressure, the formation volume factor, solution gas oil ratio, and lastly, the compressibility. There were 4 methods used. There were 4 core samples that were used, and 2 were taken because it passes the test and the result for the PVT analysis report. The sample that were used is the 3359 and the 6079. Without further ado, let's move on to my next group members.
Hello, Assalamualaikum, and hi, my name is Muhammad Farid Ikhwan bin Zawawi. My ID number is 22012027, and I would like to explain about the question A. Okay, for the question A, divided by 2 parts. First part is the determination of the saturation pressure from the intercept of 2 lines below the bubble point and also above the bubble point. For the second part is the comparison between the value that we got from the reported PB from the CCE test, the viscous index correlation, and also the plug-in function. Okay, for the determination of the saturation pressure line, first let's take a look at our first sample. For our first sample, we plot the graph and also the line with the change in volume versus pressure, and we got the first line below the bubble point, and above the bubble point we got the intercept. The intercept is the saturation pressure, is our saturation pressure is around 2648 psia, and we calculate for the viscous index, we got the different value, and also we calculate for the plug-in function, we got the different value, and we take as the references for the SG first. For calculate the SG first, the references we take the CCE test, and for the viscous index, and the plug-in, we must to make the value almost the same like the reported PB from the CCE test. Then we need to change the variable, that is SG, specific gravity of gas, because the SG is one of the variable that we use to calculate both of the value, viscous index and also the plug-in function. And after we calculate, we use Gold-Seed function, and then we got the viscous index SG, we got the different value, and also plug-in SG, we got the different value, and the value for the viscous index and also the plug-in, we got almost the same like the reported PB from the CCE test. And then for these three value in PSIA, we compare the value with the intercept of our 2 line, the saturation pressure that we got earlier. Then we got the percentage difference is around 0.906%. Is very acceptable. We move to our second sample. For our second sample, we also use the same method and procedure to analyze this core sample. First, we plot the saturation, we plot the graph below bubble point and also the above bubble point. The saturation pressure that we got is 3061.85 psia, and also we take as references the reported PB from the CCE test. We got 3086, and the viscous embed we use the Gaussian function, and then we got 3086, and plug in we use the Gaussian, and we also got the same value. And for the viscous embed we use Gaussian, we got the different value of SG, and also the plug-in we got the different value of SG. Okay, and then we got the three same value for the reported PB from the CCE, viscous embeds, and the plug-in, and we compare these three value with the value that we got earlier at the intercept of our graph. Then we got the percentage difference is around 0.789%. Is very acceptable for this analysis. The application for our first sample is we want to check either the temperature is almost the same or almost the same, and is acceptable or not. Is our task and responsibility when we become an engineer in the future. That's all from me. Thank you.
Thank you, Farid Ikhwan. My name is Wan Shakir Zakwan bin Wan Sabri, and today I'm going to continue with question B, which is the compressibility of the oil. So for the compressibility, first of all, we need to understand what is meant by the compressibility. Compressibility is simply how easily the fluid can be compressed into a smaller volume when we apply the pressure. And for the PVT lab, we are using three different tests, which is the constant composition expansion, CCE, differential liberation, DL, and also separator test. But for the compressibility, we only use two tests, which is CCE and also DL. So for the CCE, we're gonna use this test for the pressure above bubble point, where we reduce the pressure at the constant temperature and record the measured volume change due to gas dissolved in the crude oil. And also for differential liberation, we use this experiment for the below bubble point, where we are using the same method, which is pressure reduction, until there are no more dissolved gas in the crude oil, which is RS equal to 0. And for the result, we also get 4 trend line from the measured CO from the PVT manual, correlation, plug-in, and also from the PVT equation. And as you can see below, there are two different type of graph, which is above bubble point and below bubble point. And as you can see, the trend line is actually generally when we increase the pressure, the higher the pressure, the lower the compressibility. And why is that this compressibility is important to the engineer? Because compressibility actually help to understand the reservoir performance, and also help the engineer to predict how actually the fluid will behave as the reservoir pressure drop. I think that's all from me. Continue with question C. Thank you.
Hi, my name is Abdullah bin Azhar. So today I will be telling you about the separator test. So the separator test is usually done at different pressures, such as from Core Laboratories in 1964. In this method, the graph of BO, RS, and API have to be made against pressure to find out the best separator pressure. The goal is to find out the pressure that gives low BO, low RS, and also high in API gravity. But in this SGS report that we are analyzing from 2013, the separator test is done in steps or stages, starting from the bubble point pressure, and then it will be reduced in a few stages until it reaches stock tank conditions. So the total RS and BO are calculated by adding the values from each pressure stage. So this total are used for the RS and BO, RSSB and BOSB. So there is no need to compare different pressure points to find the best conditions. So in this case, the optimum separator conditions are taken directly from the report, from the SGS report.
Hi, my name is Muhammad Fauzi bin Saiful Bahari. I will discuss about question D. As you can see below, there is two graphs, one for oil formation volume factor and one for solution gas oil ratio. So we plot three data, which is for the plug-in, viscous index and PVT experiment. We plot it so we can compare the data. So you can see the differences between the three data. It is because for the PVT, we use the real lab experiment, and for the plug-in, it depends on the software that we use, and same as the viscous index because it use a formula to collect the data. So next, I will discuss about the method we use to collect the data. Okay, so as you can see in the table, this is the data for solution gas oil ratio and oil formation volume factor. The method we use is we use a formula and Excel. We put the equation in Excel and collect the data. Like for the BO above bubble point, as you can see the formula, we use the relative volume times the BO SB, that which is constant. So the equation we put in the Excel and the data we put in the equation that is suitable with the formula. But for the solution gas oil ratio, for the above bubble point, it's constant, so we don't need any formula. For the below bubble point, we also have the formula. So as you can see the formula, we just put the equation in the Excel and select the suitable data and put it in the equation, and you can get the data. So this is the method we use, and the table show the data result we get by putting the equation. Okay, in the table it shows all the data we need to collect for the question D, which is the data for oil formation volume factor and the solution gas oil ratio. That we use three methods, which is the PVT experiment, plug-in and the viscous index. For the PVT experiment, I have explained before. So for the plug-in, as you can see the format, we just need, first we need to insert the PVT file in the Excel and just follow the format and pick suitable data, put in the format, and you can get the data easily. But for the viscous index, we have a formula. For the bubble point, above bubble point, for the BO, just put the equation in the Excel and select the suitable data into the equation, and you can get the data for the BO above bubble point. And for the RS, it's constant, so no need use formula. For below bubble point, for the BO, first we need to get the CO, so just use the viscous index formula for CO, compressibility, and after that we use the formula for BO below bubble point, and we can get the data. Same as the RS, just use the formula, insert in the Excel and select the suitable data in the equation, and you can get all the data. So this is all the data that we get for the question 2, sample 2. Thank you.
Hi, it's me again. Well, first of all, thank you to all of my group members for presenting about their PVT analysis report based on their question. Here I am again, about to present about the summary or to conclude about what we all learned during the PVT analysis report itself. First of all, during the lab tour, as mentioned before, during the lab tour, what we can say and what we can learn is about the basic concept of the PVT itself. The second one is the material and apparatus used during the PVT analysis or the PVT experiment. The third one is the risk while handling the experiment and the precaution while handling the PVT experiment. From the lab itself, we all can conclude that there are two different tests to do the PVT experiment. which is the flash test, and the differential test. The third one of what we learn is that we learn how to find the bubble point, the formation volume factor, the solution gas oil ratio, and the compressibility itself. Apart from all of that, we all can conclude that there is importance in PVT data itself. First of all, PVT helps to ensure accurate reservoir stimulation. Second, it optimizes production strategies for the engineer. And then lastly is it can impact the economist's decision by recovery estimates. That's all from us. Assalamualaikum warahmatullahi wabarakatuh, and thank you.